Welcome to another episode of learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. This is my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the CSIR National Eligibility Test July 2025. And in this video, we discuss the solution of an ordinary differential equation from the section ODE. And the question is related to the solutions of second order homogeneous linear differential equation of the given type. This question is placed in part C and it is a multiple select question. There may be more than one answer. It carries 4.75 marks. The question ID is 562954168. Further, this question is suitable for all these examinations. Right. The given question is for a continuous function q, note down, for a continuous function q defined on R, consider the ordinary differential equation, that is ODE, d square y by dx square plus q of x y is equal to 0, x belongs to R. Then which of the following statements are false? We have to find out those statements which are false. We are given four options. Option 1, there exists a q such that cos x and e power x multiplied by cos x are solutions of ODE. Option 2, there exists a q such that sin x and cos x are solutions of ODE. Option 3, there exists a q such that e power x sin x and e power x cos 2x are solutions of the ODE. Option 4, there exists a q such that x e power x plus and x into x minus 1 into e power x are solutions of the ODE. Right. Let's now discuss the solution of the problem in detail. Now, if y1 and y2 are the solutions of the given ODE, d square y by dx square plus q of x into y is equal to 0, x belongs to R, where q of x is a continuous function, then y1 double prime plus q of x into y1 is equal to 0. Then q of x is minus y1 double prime by y1. Similarly, for y2, q of x is equal to minus y2 double prime by y2, where q of x is continuous on R. What we do is we test the continuity of q of x, right? So we consider a solution and a test for q of x, that is for continuity of q of x, and if this q of x comes out to be not continuous, then there does not exist such a q for which that is a solution. One solution is sufficient to throw away. But if you want to prove, if you want to show that there is a q of x, a continuous function for which both the solutions are, both of them are the solutions, then in each case you have to see q of x, and there it must be equal, and q of x is continuous. Then those two solutions, those two will be the solutions of ODE, and there exists such a q. There exists such a q. And if you look at the options, option 2 looks to be very, very simple and familiar for us, and that we will see in our way. Right? Right. We go to option 2. There exists a q such that sin x and cos x are solutions of ODE. Right. Let's call it y1 as sin x. Then q of x comes out to be minus y1 double prime by y1. Yes, y1 double prime is computed, y1. And you get 1. It's a continuous function. Now look for the cos x. Because it's a continuous function, we go for the second solution. y2 is equal to cos x. Then q of x is minus y2 double prime by y2. Compute. That comes out to be 1. In both the cases, q of x comes out to be 1 and continuous. Therefore, there exists a continuous function q such that sin x and cos x are solutions of ODE. Therefore, option 2, in both the cases, q of x is 1, is continuous on R. Therefore, there exists a continuous function q such that sin of x and cos of x are solutions of the ODE. Thus, option 2 is true. And we have to find out those options which are false. Okay, we continue in the next slide. Right. Option 1. There exists a q such that cos x and e power x cos x are solutions of ODE. Now, let y1 is equal to cos x and y2 is equal to e power x cos x. We take y2 because we have already seen y1 and y2. So, y2 is e power x cos x, and its first derivative is this one, and its second derivative is given here, and simplify. There is a simplification takes place, cos x cancels, and you will get e power x into minus 2 times sin x. So come down here. So then q of x is equal to minus y2 double prime by y2, that is equal to minus y2 double prime is written by y2. Simplify, you will get 2 times tan x. Is 2 times tan x continuous on R? No, it is not. So note that q of x is equal to 2 tan x is not continuous on R. Therefore, there does not exist a continuous function q such that e power x cos x is a solution of ODE. Forget about this second solution. This much is sufficient for us to throw away this option. So therefore, option 1 is not true. Getting to the next option, option 3, there exists a q such that e power x sin x and e power x cos 2x are solutions of ODE. Okay, let y1 is equal to e power x sin x, and for y1 we see q of x is equal to minus y1 double prime by y1, and that is equal to minus y1 double prime by y1 is computed, and we have found it is minus 2 cot x, which is not continuous on R. Therefore, there does not exist a continuous function q such that e power x sin x is a solution of ODE. Forget about the second one. This much is sufficient to throw away the option. So, option 3 is not true. Move to the next option in the next slide. Right. We go to the option 4. There exists a q such that x e power x and x into x minus 1 into e power x are solutions of ODE. Let y1 is equal to x e power x. Then we compute q of x is equal to minus y1 double prime by y1, and that is equal to minus the numerator e to the power of x into x plus 2 by x e power x. After cancellation, it is minus x plus 2 by x, and this is not continuous on R. Therefore, there does not exist a continuous function q such that x e power x is a solution of the given ordinary differential equation. Forget about the second one. This much is sufficient to throw away this option. So, option 4 is not true. And we have to find out those options for which are false. Therefore, the answer to this question is options 1, 3 and 4. Those are the 3 options which are false. And that is the detailed discussion of the solution of the given problem, and it is a very simple and straightforward question. Right. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Right, this is my channel. Please subscribe my channel if you have not already subscribed. Yes, I'm sure I will meet all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.